Welcome back to Tech Talks Education. We are continuing with stoichiometric calculations, and earlier on we had been dealing with the volume of a substance produced as a result of a reaction, and we have also been dealing with the mass of a substance that reacted. So right now we are going to look at calculation of just a mass of a substance produced, and then we shall also calculate the mass of a substance that produces some amount of mass. So that's what we are going to look at right now. So let's look at this number here. Hydrogen chloride reacts with silver nitrate according to the following equation. So we have silver nitrate solution reacting with the hydrogen chloride gas, and this reaction produces silver chloride, which is an insoluble salt formed as a solid. It will be precipitated together with it. So if this one combines with this, what will remain with it? The hydrogen ion and the nitrate ion, producing nitric acid. So the equation is self-balanced. According to what we can see, it is self-balanced. Now, calculate the mass of silver chloride precipitated, the mass of silver chloride precipitated when, let's see, I want to get a good mass of silver nitrate that we are going to use. When 34 grams of silver nitrate reacted completely with excess hydrogen chloride gas. Given that the relative atomic mass of silver is 108, nitrogen is 14, and oxygen is equal to 16. Oh, let us see what we are going to deal with. Calculate the mass of silver chloride. We are going to deal with silver chloride. The silver chloride, which is precipitated or formed when 34 grams of silver nitrate. We also deal with silver nitrate. So we are dealing with silver chloride and silver nitrate in this case. And you can see that we are looking for the mass of silver chloride formed, and then we have been given the mass of silver nitrate. The mass of silver nitrate that reacted, meaning that we are going to deal with only silver nitrate and silver chloride. Now, the hydrogen chloride, they have said that it is in excess. Whatever is in excess is not a definite quantity. So we are going to leave also out hydrogen chloride, just like nitric acid. We are dealing with these two. And then for silver chloride, you can see that we are looking for the mass. So, for silver chloride, let us get its molar mass of silver chloride. Oh, let me add for us here the relative atomic mass of chlorine. We shall need it. It is 35.5. So, it is equal to 108 plus 35.5. So, 108 plus 35.5 is 143. It gives us 143.5, and the unit is gram since it is mass. Then let us also look at silver nitrate. We have been given the mass of silver nitrate. So let us firstly get the molar mass of silver nitrate. So the molar mass of silver nitrate is also 108 plus 14, that is relative atomic mass of 1 mole, or means the relative atomic mass of nitrogen, 14, plus oxygen is 16 times 3. So this one gives us 16 times 3 is 48, plus 14 plus 108, which gives us 170 grams. So now let us try to get the mass of silver chloride. And what do we do? Silver chloride goes to the right hand side. Silver nitrate will be on our left hand side, since we have its mass already given. So we shall say from first principles, 1 mole of silver nitrate, which is 170 grams of silver nitrate. This one here, according to that equation, it reacts to produce 1 mole of silver nitrate, which is 143.5 grams. We are not multiplying by anything in this case because we have 1 mole of the two chemical species. And then what of the 34 grams? 34 grams of silver nitrate. This one here reacts to produce, then we cross multiply 143.5 times 34 over 170 grams of silver chloride. So this one here, you can see that these are complete sentences. That's what we call first principle. That can teach someone when someone is going through it. So let us now multiply 143.5 times 34, and then we divide by 170. So the answer is 28.7 grams, and that's the mass of, in this case, that's the mass of silver chloride that is precipitated as a result of the reaction. Now, let us also try to see another number altogether. Remember here that we did not use the molar gas volume, because the reason is the molar gas volume is only used when we are dealing with a gas. So we have not dealt with any gas, and in this case we have not used the molar gas volume. So let us look at another example here. Heated copper to oxide reacts with ammonia according to the following equation. So, heated copper to oxide reacts with ammonia and produces copper metal. It produces water and it produces nitrogen gas. Then we have to balance this equation. I have 2 atoms of nitrogen on the product side. We multiply ammonia by 2 to take the nitrogen atoms on the reactant sides to 2. Then hydrogen atoms on the reactant sides become 6. Here we have 2. So we multiply water by 3. And this one takes the number of oxygen atoms to 3 on the product side, and we multiply copper 2 oxide by 3. The number of copper atoms becomes what? 3 on the reactant side. On the product we multiply copper by 3. So this is the equation for the reaction. Now calculate the mass of copper 2 oxide that reacts with excess dry ammonia to produce let me get an appropriate value for us. To produce 12.6 grams of copper. Given that copper has got a relative atomic mass of 64 and oxygen with 16. Perfect. This is what we have. Remember the other time we calculated the mass of the product, but right now we are calculating the mass of the reactant. So let us see what we are dealing with. We are calculating the mass of copper 2 oxide. Oh, we are using copper 2 oxide, and we are calculating, we have been given the mass of copper. But then ammonia is in excess. So ammonia we shall not consider it. Likewise, we shall not consider water, we shall not consider nitrogen. We shall only consider copper 2 oxide whose mass they want us to get, and then copper whose mass has already been given. So we are dealing with the mass of copper 2 oxide and copper. So copper 2 oxide, let's first get the molar mass of each of those substances. The molar mass of copper 2 oxide is 64 plus 16, which gives us 70 plus 10 is 80 grams. Now, copper is not a compound. We have already seen that copper has got a relative atomic mass of 64, meaning that this value 64 is the same as the value of the molar mass of copper. So we shall use copper, we shall use the mass of 1 mole of copper as being 64 in this case. So let's go straight to the calculation. We are calculating the mass of copper 2 oxide, which reacts with excess ammonia to produce 12.6 grams of copper. So copper will be on our left hand side, and copper 2 oxide goes to the right for simple cross multiplication, as we already seen. So we have 3 moles of copper, that is 3 times the mass of 1 mole of copper is 64 grams. So times 64 grams of copper is produced by, then I have 3 moles of copper 2 oxide. That is 3 times 1 mole of copper 2 oxide is 80 grams of copper 2 oxide. I said it is produced by, meaning that it is a product, and copper 2 oxide is the reactant. So what of the 12.6 grams of copper? This one is produced by, then we cross multiply. So it is 3 times 80 over 12.6 grams of copper 2 oxide. And let us get the answer. 3 times 80, which is 240 divided by 12.6. So my answer here is, a minute. Let us try to take this 12.6 there, so it will be times 12.6, and then we divide by this one here, that is by 3, we divide by 64. Okay, let us get it. So it will be 3 times 80 times 12.6 divided by 3, and we divide by 64. Our answer is 15.75 grams. So that is how to go about with the calculation of the mass of a reactant, and when we have been given the mass of the product. Remember that a product which you start with here is produced by that reactant. In this case, it is 3 by 80 because there are 3 moles of copper 2 oxide whose molar mass is 80. And then what of the 12.6 grams of copper which has been given? We cross multiply 12.6 times 80 times 3, we divide by 3, we divide by 64, and we get the answer. So that is how to calculate the masses of the substances that reacts to produce some given mass of the products. And this is Step Top Education. Thank you for watching.